imagine being sucked up into a vacuum? Or maybe being taken into something like a giant spiraling roller coaster ride? Hi, my name is Miss Priscilla with the Creative Brain Learning Show, and welcome back to our series on the solar system with today's episode, Black Holes. Let's put on our spacesuits and get started. Black holes have been around for millions and millions of years, but mankind didn't know they existed until recently. Why is that? Well, black holes were first predicted by a brilliant scientist named Albert Einstein in 1915. They contributed to his general theory of relativity. Simplified, it means that massive objects can cause a distortion in space-time, which we feel as gravity. But black holes didn't get their name until the 1960s. Black holes were thought to be mathematical curiosities. They puzzled astronomers for years, thinking, how can things be consuming massive amounts of matter? Slowly, they collected evidence to the existence of black holes, and today, we are lucky enough to have images of these huge beasts. Wow, black holes are really cool, but I wonder what makes these cosmic marvels so powerful, and what is their place in the universe? Black holes are so powerful that not even light can escape it. That's crazy! They're also invisible, so we can't see them, but with special telescopes and tools in space, we can find out where they are. We know black holes are there because what we would see is the amount of space that's pitch black with no stars. How scientists find black holes is by looking at what the black hole is doing to its surroundings. We can see at the edge of the black hole, it starts to pull everything inside it. That's what we call the event horizon. Man, those black holes can really pack a punch. But I wonder, how do these giant things start? Well, black holes are just another part of the circle of life, where when a really big star dies, it becomes a black hole. The process starts when a star runs out of energy. The matter that's left begins to collapse on itself and causes a big blast or explosion. Everything from that blast collapses into the smallest point. Think of the smallest thing, and now it won't stop getting smaller. That's what scientists call the singularity. The singularity has such a large amount of gravity that everything around it gets pulled in. Gravity is when large bodies, like planets, draw smaller objects in. For example, the Earth's gravity pulls in the moon, and that's why the moon orbits the Earth. Who knew black holes could be so important to our galaxy? Well, we've heard a lot of good things about black holes and how powerful they really are. But I'm still trying to wrap my head around what it would be like to go through a black hole. I think we should ask an expert for help, don't you? Let's go tune in to the International Space Station for some help.
Time is X minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
All right, everyone. Here we are at the International Space Station with our very special guest, Ace the astronaut. Welcome to the show, Ace.
Hello, Miss Priscilla and Space Explorers. It's a pleasure meeting you all.
So, Ace, we've had some questions about black holes and what it would be like to go through one. Do you think you could help us out?
Of course I can. Well, as you know, a black hole is like a giant vacuum. It sucks up everything around it. It would be the same if we were to go into a black hole. We'll get consumed pretty quickly. See, black holes don't follow the same rules as space and time. If we were to travel to a black hole with the right equipment, we may be able to make it to the event horizon. At this point, we might fall into something called the singularity while still alive. Once in singularity, we'll be able to see the surrounding space. However, anyone from the outside of the black hole won't be able to see us because the black hole consumes all light around itself. While falling deeper and deeper into singularity, you will start to see things start to warp and stretch dramatically by gravitational forces. This is caused by an effect we like to call gravitational lensing.
Wow, sounds like something supernatural-like.
Well, I would say more cosmic-like.
Wait, what is gravitational lensing?
Oh, well, gravitational lensing is like looking through a giant magnifying glass. It occurs when a massive amount of matter, say like a cluster of galaxies, creates a gravitational field that magnifies and distorts light from surrounding galaxies that are behind it but are in the same line of sight. This is a really cool way for astronomers to study the details and remains of early galaxies that are too far away for any current telescope to observe.
That's really interesting. I can't believe we would be able to study galaxies so far away. That just shows how far humankind really has come.
Yeah, and there's still so much more to observe.
So let's go back to black holes. What would happen after the gravitational lensing?
Oh yes, of course. Well, after gravitational lensing, you ultimately keep falling deeper and deeper into the black hole, and the only way to get out is going faster than the speed of light. Again, black holes are very powerful, so I wouldn't recommend going near one anytime soon.
Wow, that sounds really scary.
Yes, but don't worry. The nearest black hole is roughly 1,000 light years away. And considering that 1 light year is 6 trillion miles, we're definitely safe from black holes. But who knows? Maybe one day we could successfully take a probe out there and learn more about these amazing phenomenons.
Well, thank you so much, Ace, for giving us some more insight on black holes.
No problem at all. Come back anytime. See you later.
Between you and me, I won't be traveling to a black hole anytime soon. But even though the nearest black hole is still really, really far away, what if one appeared in our solar system? Or if our sun became a black hole? Well, if one appeared in our solar system, the planets wouldn't be much of a fight because the planet's gravitational pull is no match for black holes. But if our very own sun became a black hole, we wouldn't have to worry about getting sucked in. We would have to worry about no sunlight coming to Earth or any of the other planets though. That means our whole solar system would become an ice ball system. Man, I'm glad there is no black holes in our solar system. And it's crazy to think that even if our own sun became a black hole, it wouldn't be as powerful. However, life on Earth would definitely not be the same. But between you and me, I'm still curious about how a black hole becomes a black hole. Let's head back to the lab. I have a feeling that this question requires an experiment. All right, space explorers, we're here at the science lab where we take all of our questions and theories and perform experiments to know what would happen. Today in our science lab, we will be testing out what happens to create a black hole using just a few materials. What we'll need is a balloon, aluminum foil, and scissors. Okay, we have our materials, let's get started. First, blow up the balloon to a medium size. Then, wrap the aluminum foil all over the balloon, covering it completely. This represents our star. Now we'll use our hand to put pressure onto the balloon the same way gravity is pushing on the star. It may not feel like anything is happening, but what we're doing is demonstrating how an old star over time starts to collapse due to its great amount of gravity. Next, we will be using scissors to pop the balloon inside the foil. Please ask an adult to help you. After that, smooth the aluminum foil into a small ball. This represents the gravity pull. The gravity pull is the pressure being put on a star as it collapses. This is what creates a black hole. All right, my lab assistants, congratulations! We have now made our very own black hole. Well, at least a model. Uh-oh, everyone! We better split before we get sucked up. Whew, that was a close one, Space Explorers. Well, I would say our experiment was a success. All right, Space Explorers, we've come to the end of our adventure today. So let's go over what we've learned. We've learned that black holes have been around for millions and millions of years, but we have to thank Albert Einstein and his theory that a massive black object can cause distortion in space-time, which we feel as gravity. This was called his general theory of relativity in 1915 for putting out there the real idea of the black hole existence. Remember, black holes were merely a mathematical curiosity and not proven to be a real thing. And black holes didn't get their name until the 1960s. We learned that we can't see black holes because they are invisible, but by using special telescopes and tools in space, we can find out where they are. Scientists observe the effect a black hole has on its surroundings. We also learned that black holes have their own really strong gravity that can pull in matter and even light. We also talked about the event horizon and that it's at the edge of the black hole. It's at that point where it starts to pull everything inside it. We learned how black holes are formed and what they start as. Black holes form when a giant old star starts to collapse on itself, creating a huge explosion. This reaction causes the large mass of the star to shrink into what's called the singularity, something that becomes infinitely small. In our interview with Ace the astronaut, we talked about what would it be like to go into a black hole. First off, I don't recommend it. One big thing is that time doesn't work the same way in black holes. It could seem like a few seconds or even a few days. We learned about gravitational lensing and how it's like a giant magnifying glass. Where there is a huge amount of matter, like a cluster of galaxies, they create a massive gravitational field that distorts light from other galaxies. This helps astronomers study the remains of old galaxies. We learned if our sun became a black hole, we would experience some real changes on Earth. For instance, we would have no more sunlight or warmth and our planet would become an ice ball. Lastly, we learned in our experiment that black holes may start off by shrinking smaller and smaller, but they keep their same mass, which is what makes them so powerful. Ooh, you know what that sound means. It's question time. I'll be asking you all the questions about facts from today's episode. Are you ready? All right, let's get started. What starts a black hole? When were black holes discovered and by who? What is the edge of a black hole called? What is a singularity? And lastly, true or false? Light is the only thing that can escape a black hole. Wow, we sure learned a lot of interesting things about black holes, but I think it's time I blast off home. Again, I'm your host, Miss Priscilla, with the Creative Brain Learning Show, and thank you for joining me in today's episode on black holes in our series, The Solar System. Join us next time where we talk about our dazzling stars. Bye!